Hello, here's my Module 5 presentation about paper circuits. I first began with the engineering design process and had to ask myself how I could use a paper circuit in my math class and how I actually construct a paper circuit. I did an experiment in the last STEM class where I used the light sensor and the distance away from the light, so I wanted to do something different in this particular class. So the task is that students would use a paper circuit, and they'd have to create the paper circuit in order to light up a specific triangle center that we would have learned about in class that they get to choose. They have to create a story about where they want this center to be located based off of the locations that they choose, and end up creating a plan, a construction plan, and a prototype that they would want to present to a board for approval, such as a township if you wanted to create a park or maybe a lighthouse or an air traffic control system. So these are the questions. This is the process that you can see once you download my lesson plan as well that the students would have to answer. So then I had to imagine what I was going to do. So I ended up imagining where would I want to place a park that was equidistant, so the same distance away from my house, my parents' house, and I actually ended up using my dad's office because I couldn't find a map that had two different counties on it. And the point of concurrency that I would have to find would be the circumcenter, which is constructing the perpendicular bisectors of a triangle because it is the same distance away from the vertices. So first I ended up trying to create my paper circuit. So here are my materials, and then I started out with a sketch of my plan. I created the paper circuit using the copper and a 9-volt battery. The light ended up turning on right away and it was really bright, and then all of a sudden it just shut off. So I had to actually redesign this circuit again, and I wanted to make sure now that I put the copper over top of the LED light because I wasn't sure if that was the issue. And I also went back to the store and got another set of batteries that was less voltage and they were flat. So when I did that, it actually did work, which was good. But the batteries, I definitely had to press down on them. That's why I put a paper clip over here because they were a little loose, so the light was flickering. From there, I then had to go back to the mathematical task at hand, which would apply to my Common Core standards in my 8th grade math class. And over here, you can see a triangle that I created from our 3 locations for what I would be creating, but this is 100% up to the students and what they actually want to place and what they want to create and try to build. I then had to find the midpoint of each of the triangles to create a perpendicular bisector and use the appropriate tools in order to find that. So you can see here, this is the point where the 3 lines intersect, which is called the point of concurrency. That would be a circumcenter. And then I put the light through the paper because the task is to light up that point of concurrency because that's what you would want to create in your prototype and your model and into your plan if you wanted to present this to maybe a township or to a board for approval. So according to the STEM practices for science, I believe that students would definitely be analyzing and interpreting the data that they would collect, and they would have to construct an explanation about why what they constructed was correct. So you have to actually do your measurements at the end, because in my case, the light ends up being on our scale model 2.5 centimeters from each of the vertices, which means that it was the accurate placement. As an engineer, they have to come up with their own plan, and they have to develop and use a model to represent this plan to present it to a board. For technology, they're becoming aware of a system that societies use, specifically when you're doing construction or looking for the location of a new building. And then for math, they're making sense in problem solving and persevering. They're using appropriate tools strategically and attending to precision. And then let's see if I can move my picture. For our design tools, I believe that it was very heavily STEM related. The only ones that I knocked it down a little bit for was, does the lesson present a real problem? And it could potentially represent a real problem, but probably they're not going to put a park in between just specifically my parents, my sisters, and my house. So it could definitely relate to a real world problem if students talk about maybe where to build a watershed or where to place something in order to deal with a problem that their community is dealing with. I also said the role of technology in the lesson is clear to students. I said somewhat because there's not a lot of technology involved, but there are definitely programs and softwares out there that would allow for programs as well. And then this last slide would be my references, and you can find further more of my lesson plan attached on D2L. Thank you.